All right, well, we're going to start graphing rational functions in this section. And up there in the blue writing, you can see just a little bit of a review of what rational numbers mean. So I just wanted to remind you that a rational number is just pretty much a fraction. The definition states that a rational number is something that looks like this right here, a over b, where a and b are integers, and of course b cannot be 0 in this scenario either, okay, because that would make it undefined. So really what we're talking about is fractions when we talk about rational numbers. So a rational fraction then is just a function, I'm sorry, a rational function is one that involves fractions. So that's what this right here means. F of x, a rational function, is involving a fraction that has a function in the numerator and denominator. All right, so that's the definition of a rational function, and the parent function is going to look like this graph here in green. So the function itself will take this form, the parent function, y equals 1 over x. That should look a little bit familiar to you because if you look over here at the first form of these that we're going to talk about in orange over here, the y equals a over x, that's the inverse variation form that we talked about in the section 1. All right, so this is that form where we went and looked at functions and tried to decide whether they showed direct variation, inverse variation, or no variation at all. This was that form from that worksheet. So the parent function is going to take that form, and in the parent function, the a value will be 1. So that's kind of similar to parent functions in the past, just this most simple form of this rational function. It's going to look like this over here that I have graphed out. The asymptotes, there's going to be two on these rational functions. So there's going to be a vertical asymptote and a horizontal asymptote. So this one, the vertical asymptote on the parent function is the x-axis, so x equals 0, or I'm sorry, the y-axis of x equals 0. So that's what we're talking about here. That's the vertical asymptote. And then the horizontal asymptote is the x-axis, y equals 0, right here. Okay. And once you have those asymptotes in place, we would put in a couple of numbers into a table to the left and to the right of those asymptotes, and that's how we get the actual drawing. The domain in the parent function is going to be anything except 0, and the range the same. Y cannot be 0. All right, so this is in general what these are going to look like. We're going to have three forms of this, so moving over here to the right part of the screen, this is really what you need to have written down in your notes, these three forms, because in the first form, the asymptote, if it takes this form right here, the asymptotes will be the x-axis and the y-axis, so we need to know that. If we have any shifting, that's what this form right here in green is showing. You can see your h and your k values show up here. So that would be if there's horizontal shift or vertical shift or both. All right, if there's no horizontal or vertical shift, that's when we end up with the form that looks like number 1. All right, so if they're shifting, then your asymptotes are going to change, of course, because we're shifting left and right, up or down. The vertical asymptotes will be whatever your h value is. Okay, so that's how you're going to get your vertical asymptote. You would come over and find your h and draw on that vertical asymptote there. You're going to get the horizontal asymptote by looking at the k value. Okay, so in the parent function, the h and k values are both 0. That's why they're not written in, just like we have seen in all the previous functions we've done. And then the third form looks a little more complicated. Ax plus b over cx plus d. So full binomials in the numerator and the denominator. Those are going to be a little bit more challenging to find the asymptote. Still not difficult, as long as you remember that we're really, to find the vertical asymptote, we're going to set the denominator equal to 0 and calculate our x out. And to find the horizontal asymptote, we're going to put our a value, this first term, so the coefficient on the x term in the numerator, and we're going to put that over top of the coefficient on the x term in the denominator. So a over c. So not complicated. We just need to remember the definitions for each of those. All right. So moving up to the worksheet, let's take a look at number 1. They've asked us to find the vertical and horizontal asymptotes. So we're going to look at our function here and recognize that we have one that falls under form, that second form. So this form right here that has horizontal shift and vertical shift. Okay, so we've got both. So what we need to do is find our h value, make sure that it's written as a difference, which it is up here at x minus 2. So it needs to be a difference. So that means that our h value is 2 and our k value is 1. All right, so the h value is going to line up with our x asymptote, our vertical asymptote. Actually, I'm going to write that in as vertical. So this is our vertical asymptote. And then our k of 1, that's our horizontal asymptote. Okay. And we'll practice with those on the bottom when we start graphing these. On number 2, here we can see we have a full binomial in the top and in the bottom. So that lines up with our form 3, the one that looks like this, ax plus b over cx plus d. Okay, so now to find our vertical asymptote, we're going to take the denominator, the cx plus d, which is this right here, and we'll set it equal to 0. All right, and we'll end up with x of 4/3. So this means that our vertical asymptote is going to fall at x of 4/3. To find our horizontal asymptote then, that's when we follow y equals a over c. So in this particular problem, the top coefficient, our a, is 2, and the bottom coefficient on our x term is 3. So our horizontal asymptote is going to fall at y of 2/3. All right, and I'll come out here to do number 3. We've got form 3. We have a binomial on the top and the bottom. So I'm going to set the denominator equal to 0 in order to calculate my vertical asymptote. All right, so vertical asymptote at 3/2. And then to find my horizontal, I'm going to come over here. I can see my coefficient in the numerator on the x is 1, and the coefficient in the denominator is 2. So here I have my horizontal asymptote at y equals 1/2. So now we're going to move down to 7, and we'll use this this idea and this skill in order to actually graph these. All right, so the first thing we need to do here on number 7 is actually calculate or figure out which form it's in. And so this we can see is in that second form. So that's the form that looks like this with a horizontal shift. In this case, we don't have a k value out here, so that tells us that we don't have any vertical shift. But we do have some horizontal shift. Now, the x plus 3 in the denominator needs to be rewritten as x minus a -3, so that we have it written as a difference here. Okay, so from that we can see that our h value is -3. So that means that at x of -3, so x -3 is going to be our vertical asymptote. And then our horizontal asymptote is 0. So y equals 0 is our horizontal because we don't have any shifting. We don't have a k value written out here. That means that, it really is 0. They're just not writing it in. All right, so we've got our two asymptotes. We're going to take those and we're going to put them onto our graph. All right, so there we are at vertical asymptote at -3 and horizontal at y of 0. And so now we're going to make a table, a small table of values. We don't need a lot of points, but we do need to be a little bit more thoughtful about the points we plug in. So we're coming in here and looking at where these two asymptotes intersect. And I want to take 2 points on the x-axis to the right of that first. So I'm going to look over here and I'm going to see that I could plug in 0. That's to the right, and that would be easy to calculate that. If I plug 0 in for x here, I'm going to calculate that and I'll get 2/3 out. And then if I kind of look again at some numbers over here, I'm not going to go too far this direction. I'm actually going to come back a little bit closer to where they intersect, and I'm going to pick x of -2 right here. It's still to the right of where, what I'm looking at is right here where these intersect. And so I'm going to pick x of -2. When I evaluate that in, which I'm not going to show you, take the time to show all that algebra, but we'll get 2 out of that. I know you guys can do that part of it yourself. Okay, so now let me go ahead and plot those two. 0, 2/3. So x of 0 is right here, 2/3, and then x at -2 gave me a +2 here. So I can see that between those 2 points and my asymptotes there, I can actually draw in that first part of the graph. Now to get the second half of the graph, I need to go to the left of the intersection of the two asymptotes. So I'm going to pick a couple of points on the x-axis to the left. I'm going to try -4 right here. And when I evaluate that into the table, I'll get a y of -2. And then I'm going to move out one more space to -6. And I'll get -2/3 there. So then I'm going to come in and plot those two. So I'll go x of -4 is going to take me here to -2 on the y. And then -6 will give me -2/3 right here. Now, using those 2 points and the asymptotes, I got to stay within those asymptotes. I can't cross them. I can draw in the second part of the graph. All right, moving to number 8. This one looks like form 3. So to first step, calculate our asymptotes. I'm going to get my vertical asymptote by setting the denominator of x minus 3 equal to 0. So I'm going to get a horizontal asymptote at x of 3. And then my y asymptote is going to be calculated by taking the a value and putting it over c. So my a here is 1, my c in the denominator is 1, so my y asymptote is y of 1. So there, that will be, oh, actually I have that reversed here. This is going to be our horizontal. This right here should say vertical. Okay. All right, so I'm going to take these and pause the video and write those in, those asymptotes. All right, so now I'm going to go back and get a couple of points for my table. So first step there is find where the two asymptotes intersect. So I'm talking right here, and I'm going to go to the right and grab an x of 4 and an x of 6. When I evaluate those in, I'll get 5, and for 6, I'll get 7/3, so just a little bit over 2. And then from that point again, from the intersection, I'm going to go to the left. I'm going to get this 2 for my x, and I'm going to evaluate it 0 as well, because that one's easy. I'll get -3 and a -1/3. All right, and then we'll plot those points. 4, 5, and 6, and almost 2 right here. So using those 2 points and the asymptote, I can draw that in, do the same thing on the other side, 2, -3, and 0, -1/3. And there's your graph. Now, number 9 is also following form 3. Even though we don't have a full binomial, we only have one term in the numerator, we have an x term. So because we have an x in the numerator and in the denominator, we're going to follow form 3. So we'll calculate our vertical asymptote by setting the denominator equal to 0. And so our vertical asymptote is going to be x of 1/2. And our horizontal is going to be 2 because I'm setting 4, the coefficient of that x term, over the coefficient of the x term in the denominator. So y of 2 and x of 1/2. Okay, so with our asymptotes drawn in, we're going to make our table come here where they intersect and go to the right. I'm going to do point x2, I'll get 8/3 for y, x of 4, I'll get 16/7. So of course we're going to think about those as almost 3 and about 2 and almost 2.5 here on that other one. And then I'll go to the left, and our asymptote right here is at x of 1/2. So that means that 0 does fall to the left of that. So I'm going to use 0 because that's very easy, because I'll also get 0, 0. And then still to the left of that is -2. So remember, when you're finding these values for x, you're finding 2 of them to the right of the intersection of the asymptotes and 2 to the left. That way we cover enough ground on the graph that we can get a picture of what each side is going to look like. And I'll get 8/5 here. All right, plugging those in. Here and here on this side, and then connecting those while staying within the bounds of the asymptotes, and then 0, 0. And we'll do the same thing over here. Now, one other thing we need to talk about before I erase this graph right here is domain and range. And the domain and range on these are pretty straightforward. The only, for our domain, we have an asymptote here at x of 1/2. So we have an asymptote right here, and we know that we can't touch it or cross it. So as far as our domain is concerned, the only x not allowed on this graph right here is x at 1/2. So the way we say that is that our domain can be all real numbers except 1/2. If we put an x in a 1/2, we're going to be on the asymptote, and that's undefined. We're not allowed to do that in these types of functions. So that's why we exclude 1/2. The same idea applies for the range. If the asymptote is at y of 2, well, we can't have a point on it or crossing over it. So all reals are allowed, all real numbers, except for 2. And it'll be like that through all of these problems. Whatever your vertical asymptote is, that's going to be the point excluded from the domain. Whatever your horizontal asymptote is, that's going to be the point excluded from your range. All right, and then moving down to our last problem to talk about is this word problem at the bottom. Your local phone company charges a $65 installation fee and a monthly fee of $32. They say let X represent the number of months of phone service and write an equation that represents the total cost C. So this should be pretty straightforward for you. The total cost, of course, is going to come from taking the $32 for the monthly fee and multiplying it by X, whatever that number of months that you actually have the service. And then we're going to have to, of course, add to that $65 installation fee that is there regardless of how many months you actually use the service. So there's a nice linear equation. And so that part is pretty straightforward. Coming down to number 14, they ask you to write an equation that represents the average cost, A, per month. So remember our months, they told us up here to define as X, and now they want us to find the average cost per month. This linear function here represents the cost, and if we're going to average it out per month, so this is our total cost, then we will say, let's take that total cost and let's divide it by the number of months that we actually have the service. So to make it, just kind of put it into more simple terms, we're taking the total bill, which right now is represented by that function 32x plus 65, and we're going to divide it by the number of months. That's just the definition of average that we're using to write this complicated rational expression. I'm going to let A equal our average. And if I kind of pull that out and show you the form we have here, the form right now is saying that A equals C, because we're calling this the function in the numerator C over X. And you can see that it does show that first, that kind of simplified form of the inverse variation where X is in the denominator. Okay, so what we do from here to graph it, they asked us to graph it in 15, is we're going to follow the same steps. Where we have form 3 here, so because we have an x in the numerator and denominator. So we're going to set the denominator equal to 0 to find our vertical asymptote. So vertical asymptote is going to be, that was easy, at x of 0. And then our horizontal asymptote is going to come from A over C. So our A value, 32, over our coefficient on this term of 1, that'll give us a horizontal asymptote at 32. Right, so my asymptotes are drawn in, and you can see from the graph, we're really only concerned about positive values. I mean, we're talking about the average cost, so we're talking about a positive number. That's why they have disregarded the section of the graph to the left of the vertical asymptote. So we're just going to pick 2 points to the right of the vertical asymptote. I'm going to choose x of 10 and x of 5, and those are pretty easy to evaluate in. I'll get a y of 38.5 when I plug 10 in to my function here, number 14. And then when I plug 5 in there, I got a y of 45. So just to back up a minute and go over what this is actually telling us, the information this point right here gives us is we're saying that if we had this service for 10 months, we're going to have this, the numerator is going to tell us our total bill, and then we're going to divide it, though, that total bill by 10 months again, and that will give us the average cost. So if you have the service for 10 months, over 10 months, you're going to be paying about $38.50 on average per month. If you only have it for 5 months, then your cost is the numerator, and you're going to divide it out by 5 months, and you're going to get the average cost of $45 per month over that 5 month of service. All right, so then from there we need to go in and plot these points into the graph and draw in our graph. All right, and then the last thing they ask us is how many months until the average cost per month is $33.25. And so what we can do there is take our function and in number 14 and evaluate in at 33.25. All right, we'll solve for x. Get rid of that x in the denominator first. All I did was just multiply by x on both sides. And subtract the 32x from the right. We'll get 1.52x equals 65. And then that's going to end up giving me an x of 52 months after I do the math with those fractions. So after 52 months, our average cost per month is going to drop down to $33.25. And that makes sense because you're spreading out that $65 installation fee over a larger number of months the longer you have the service. And of course, another way to do number 16 would be to plug in to your calculator the function right here at number 14 into your y equals, you would need to put some parentheses if you were going to do it that way around that numerator. And then you could graph it. You could hit the trace button and take it, the trace button, until y equals 33.25, and that would take you to roughly 52 months. We just can't see it on our graph because we don't have that point. The graph doesn't extend that far, so we can't read the graph that we have drawn right here on the paper. Or you could do that on the graphing calculator as well. So either way, either evaluating at 33.25 or actually putting it on the graphing calculator, either way will work.